Hello, everyone. Um, Today, my colleagues and I are going to be talking about ways to convey science in writing. My name is Lydia Allen. I'm the director of the Writing Center, and my focus is on scientific narrative and storytelling.
Hello, I'm Nick Zarevsky from chemistry, but I also teach at Siemens some of their doctoral of liberal studies classes, like history of science and philosophy of science.
I'm Gary Evans, a faculty member in the electrical and computer engineering department, and I have one course that has the writing tag that I'll be talking about today.
Okay, so I'm going to go ahead and talk about narrative in STEM, how storytelling helps shape STEM communications. If you'll go ahead and advance the slide. So people typically don't think of scientific writing as being narrative in nature. They think of it as being informative. But the way that we convey science, not only to other professionals, but also to lay people, is oftentimes through a narrative or storytelling mode. So the question is why? Why use narrative? Well, first of all, stories create a pattern of organization for information, and they serve as memory structures in that they are easier to comprehend and more memorable than a set of bare facts. So if we want folks to really understand and remember what we're teaching them or conveying to them about science, it's often very helpful to structure it in such a way that they can remember it better. And storytelling is one way to do that. Stories also serve social goals such as group cohesion, learning from others, forming beliefs, and communicating ethics and values. We often think of science as sort of ivory tower, like objective fact creating endeavor, but in fact, science is culturally constructed. It is an endeavor that we engage in as a community because we have peer revisions and we have peer reviews and we have conferences and all kinds of ways. And so when we develop a story, it can result in some of these pro-social side effects. Science is a sociocultural activity, and social knowledge relies on and references human concerns and meaning making. So, why do we learn the things we do in science? Because it's part of what it means to be human. It often conveys or is part of a story of, for instance, healing or discovery or other sorts of things. And these are meaning making activities. Engaging in science is oftentimes a meaningful act. So, thus, STEM stories serve to inform and persuade their intended audience by taking complex information and making it more accessible and meaningful. And I think the key word here I really want to stress is this word accessible. I think as scientists, we have to do the best job possible that our work in writing is accessible to other people because there's a lot of purposeful obscurity in science writing to kind of try to make the science sound sort of high minded. And I think it's really unnecessary because, sort of like complicated writing is hard to unpack. And really, truly, the language should be clear and it should be accessible because it's the ideas that really count in that communication. Okay, go ahead. Next. So, what is narrative in STEM? It is the descriptive account of connected events that the author uses to convey their intended message to the audience. So, as you can see here at the bottom of the slide, I've got a link there to an article by Nathan Nee where he talks about a research pattern of establishing, proving, and convincing. And so this is one type of pattern we can use to develop a kind of narrative. So he likens the scientific journey to the hero's journey that we have all learned about, Campbell's hero's journey with Star Wars and all these kinds of things. So he says that the scientist's journey involves a call to discovery, study initiation, experimentation, re-experimentation, data acquisition, and contextualization, all important aspects of communicating science. All right, let's go to the next slide. So I've included in this slide for folks that want to dig a little deeper some additional sources. So the top one is about storytelling, and the next one, Joshua Schermel's Writing Science. This is a wonderful book that people can use in their classes. If you wouldn't mind clicking on that and opening that book up for me, I've sent you the PDF here just to look at. But if you're wanting to really teach writing science in your class, this is a wonderful book to consider adopting for that. So let's have a look real quick at the table of contents, if we may, so you can get the idea of how he set this up. There we go. So as you can see from the table of contents, he talks about science writing as storytelling. And then if you go on down to chapter 5, you have the opening, the funnel, the challenge, the action, etc. This is how you would actually set up your lab reports to accomplish this kind of storytelling. So there's a very detailed list of how to do that. And it uses a number of examples directly from scientific writing. And then at the bottom, you can see there's sort of like stylistic concerns with paragraphs, sentences, flow, and etc. So I really, really recommend checking this book out if you're wanting to really teach scientific or STEM writing in your courses. Okay, so let's go back to go to the next slide. Okay, so again, a few more links here. Storytelling in Science Writing from the University of Guelph is a great website. If you wouldn't mind clicking on that just briefly.
I'm so sorry, which one?
The top one,
Oh, here.
please. Okay, so let's just kind of skim this. We'll scroll down. He gives us, if we scroll down just a little bit more, he gives us a few structures. He gives us the and, but, therefore, ABT structure. And if you scroll down a little more, yeah, so he gives you examples and exploring the ABT structure. And then if you scroll down further, there's, I think there's one other structure. He goes through the ABT structure for quite a while. There's some pages you can download. And then he discusses these different ones, the and versus the ABT versus the despite, how, or yet. So the reason I'm pointing this out is because you will find other science communicators referencing this and, but, therefore structure in their own recommendations of how to structure your stories in your scientific work. So, okay, so let's go back to the slide we were just on. I included at the bottom a scientific presentations because we don't just communicate in writing. Frequently, we do poster presentations and panel talks and all kinds of things. So there's an article there from Nature that talks about compelling stories in scientific presentations. All right, can we get the next slide? Okay, so one of the things I really enjoy talking about is communicating science beyond research communications. And in this sense, we're talking about public facing work with lay people. And it's really an important aspect of science that I feel like occasionally gets overlooked because folks are oftentimes so busy with their own research and they've got a lot of demands on them in terms of producing and publishing and other sorts of things. But I do think that the public facing work is important because we are dealing with times where there is a lot of misinformation and disinformation about science. There is a significant eroding of the public trust in scientific expertise, and there's a ton of polarization right now. And I feel like that those of us that have worked in the scientific field have a kind of responsibility to try to find some time to address this if we can. So ways that we can do that are through things like STEM blogs, STEM journalism, and how these operate in terms of getting the information out to sort of the lay public. That link at the bottom is about the roles of blogs and news sites in communicating some of these issues. So what I think is interesting about this is that it's a kind of assignment you can give your students that is slightly different from the research, but it's so helpful because if you can take something as complicated as a research question that's very technical and very specific. And you learn to have the ability to tell the story about it to someone who is not also a technician in that area. You demonstrate a deep level of understanding at that point. And so I think it's a really useful kind of activity to do in a course. So perhaps after the end of the course where you've developed the research, have an assignment at the end where students will maybe offer up a blog entry talking about it, why it matters, and what it means for, all of us. So, okay, so that's kind of my spill. I think that's my last slide. Oh, I just want to plug the Writing Center. So if you would like further assistance with designing lectures or assignments, please reach out to me. That top link is just my bio, so you can kind of get a sense of what I'm about. And my email is there, lrellen@smu.edu. I am very happy to work with professors to try to get sort of a culture of writing established in our schools, especially in our STEM courses. All right, thank you. Thank you. Let me hand this over to Nick.
Is this the next one?
Yeah,
great.
No, the other one. Well, while we're switching slides here, I just want to thank Lydia for giving a nice introduction to what I will say. This is really mostly from a class that I teach, we teach in chemistry for graduate students. It's called Chemical Communications, and this is mostly about how scientists communicate with other scientists. And we heard about how important it is to communicate to the public. And I'm a huge supporter of that, using various approaches to make science digestible and fun to the public. But this really is a class which is communication, scientists communicating their results and their findings to other scientists. Some of these slides are actually taken from another humanities type of class called Science and Society, which is really history and philosophy of science. So by the time I show this presentation in the chemical communications class, we have taught the students how to do literature search, how to find original sources. So that these are the first things. And this is really how to write a paper and what is involved in preparing a paper, and also the reviewing process, peer review itself. So we can go to the next slide. I usually like, that's the historian in me. I like to show them, because we teach them about style, writing style in science, and style is something that has changed immensely. If you look at the very first, or one of the very first scientific journals ever, which was the Philosophical Transactions of the Royal Society in England, this is the paper, scientific paper by the great Robert Boyle, a chemist, physicist. Many people remember Boyle's laws from physics, probably the gas laws. And this is a scientific paper published in 1672, and I usually give my students, so I usually ask them to find that paper, to find a source, to download it and read it, and analyze it both for style, but also do a little bit deeper analysis. So this is the very first sentence, just to show you, speaking of style, scientific writing. Yesterday night, when I was about to go to bed, a amanuensis of mine, accustomed to make observations, informed me that one of the servants of the house, going upon some occasion into the larder, was frightened by something luminous that she saw, notwithstanding the darkness of the place, where the meat had been hung before. Whereupon, suspending for a while my going to rest, I presently sent for the meat into my chamber, and so on. And this is, by the way, one sentence, the whole thing. So this is not how we start scientific papers now, with personal experience. I think it's fun to just to see maybe the humanity, if you will, of the scientists, right? So we're not telling stories in that way anymore. However, this is really a scientific paper. And so on the next slide, these are the assignments that I actually like to give students. So analyze this paper by Robert Boyle. What makes it scientific? And what makes it not so scientific, perhaps? In his scientific assumptions, he describes numerous experiments there. What assumptions, if any, were made? What did he forget about that we know about now, but he didn't at the time? And what are potential sources of error? So analyze it as scientists looking back at something that was written, not quite 400, 350 years ago. And then, because any paper, scientific papers, requires an abstract, a summary. That's usually on top of the paper in any scientific journal. I told them, well, grab this paper and now kind of redo it in a contemporary language, write an abstract of this paper, 500 word abstract. And then without sacrificing any of the information, that's the next part of the assignment, without sacrificing any of the information, cut it by half, 250 words. Just to teach them that you can actually find ways, creative ways to succinctly express something, but that requires a lot of work, a lot of thinking. So this is a very nice exercise using this very old original paper. Occasionally, I used to do that back in the day. I don't do it anymore. I ask them to rewrite the introduction to make it more contemporary, just the same information, but without the fluff, so to speak. So this is how we start talking about style. But then, of course, on the next slide, we give them some literature. Lydia showed actually some wonderful sources about style and writing. This is specifically for chemistry because that was from a chemistry class. But there is a book called The Chemist English, written by it's a very witty, pleasant to read style, humorous, with some proper and not so properly written articles from the past, but also a couple of papers. One of them is recommending how to write a scientific paper, what to include, what not to include, how to do it succinctly, effectively, and also how to write a review article. So these are some very useful sources. They're here on the bottom. I'm sure you cannot read actually from the slide, but if you're interested in these sources. So the next slide. We actually now go into the various types of the publication process itself. And so we describe the various types. I mentioned already the word review and regular articles, but we introduce the students to all the different types of scientific publications. There are some that are very short, things like communication, for instance. These are very urgent, kind of very brief, because there's something very important discovery was made. You want to communicate it as quickly as possible. It usually does not have many details. Notes, which is kind of old-fashioned now, doesn't really exist anymore. But back in the day, these were even briefer, some kind of observation that you want to share with the community. And all the others, the typical papers, reviews and mini reviews and all these types of papers. And occasionally, of course, we would ask the students, not occasionally, we would ask them to find some examples and share with the class something that's from their area of research. Now, when a student actually writes a paper, of course, they have to decide, is it going to be a very brief communication? Is it going to be a full paper? Or is it going to potentially be a review paper that summarizes the state of the art in a specific field? And then we go into how, once the paper, we know what we'll be writing, we have to think about what type of journal. Of course, it has to be relevant to the type of research. We want it to be widely read so people can see that paper. So the next slide, we go into a little bit more detail. So this is the anatomy, if you will, of a paper, right? It starts with an abstract, and they already have some practice trying to write an abstract for Robert Boyle's paper or any other I can give them. What it is. So we explain that it's not a rewording of the paper itself. There is no introduction in the abstract. There is no conclusion in the abstract. It's really the scientific findings that very quickly summarized, so that reading those probably 5, 6, 10 lines, maybe a paragraph, one can know what exactly was novel, what was discovered in that paper. Then we go into introduction, what it contains, and there are things that, what is the goal of the work, what is the current state of the art, what is missing, and why are we the writers, the scientists, why are we needed to actually do our research, what are we solving, what kind of problem. So this is all in the introduction. So these are some types of advice that we give students. And then we go into the next slide. How to write experimental section. Students in the STEM field are actually notoriously bad in writing their experimental sections. They put all kinds of irrelevant information, and at the same time forget a lot of really important details. Right, so this actually is quite a lot of practice to write a proper experimental section. So very briefly, what is normally required, how to describe the procedures, But also things that they, just put a space between number and unit, these types of small things that are cosmetic probably, but still important. The paper needs to look also professional. And of course, the main goal of a paper is when you read the experimental section, anybody reading that experimental section should be able to reproduce, using the same types of instruments or chemicals or whatever was used, or cells, maybe if it's biology. They need to be able to reproduce your paper and hopefully get the exact same result that you did. So do not obscure that, which very often actually happens in the literature, even in very prestigious journal. Still, there are some details missing. So we try to teach students not to make these mistakes. We can go to the next one. And then this is really the meat, so to speak, of the paper. It's called the results and discussion section, where all the data is presented, it's analyzed, plots and figures are made, and some calculations maybe. So this is what the observations are, the analysis of those observations, and really the main conclusions. So it leads to the conclusion sections, which is normally the next one. But so this is really the meat of the paper. And then conclusions, what was actually discovered. Sometimes in conclusions, one can say, well, what was missed, what the next directions will be. Okay, something was addressed, and there are a new question open up, and so we need to address it in the future. And then various types of things, such as acknowledgement, funding sources, of course, need to be acknowledged, and all these things. These are small details. So we can go to the next one. Okay. And then we discuss something which is certainly for starting students, the publication process itself, it's a very complicated thing. It's not as easy as we think. So who will be interested in this work? That's the main question, of course, which means what kind of journal we should select and what are the criteria? How do we judge the reputation of a journal? Prestigious journal, more likely to be read, more likely to be seen, of course, but every journal is evaluated by this very magic number in science, impact factor, and this really tells you statistically what is the likelihood of your paper to be cited based on other papers published in that journal. People get a little too obsessed with this impact factor, so we have to explain to them what it means. It's really statistically, over a period of time, the average paper in that journal, how many times it was cited. And I always tell students, do not be too proud that you have published in a journal with a very high impact factor. Only be proud if your paper, after certain years, gets more citations than this number. That means it's more than the average, because if it gets fewer citations than the impact factor, maybe it was not a very high quality paper. So we'll see how we judge actually the impact of a scientist or specific paper or specific person rather than a journal. But let's go to the next slide. And then we go into the reviewing process. What happens when the paper is submitted to the journal? It goes to an editor. The editor may decide to reject it immediately if it's not sufficiently high quality, or send it to reviewers, 2, 3, 4 more potentially. And then what the reviewers are supposed to do. So normally, ideally, the ideal reviewer should help the authors improve the paper, and with some good suggestions, constructive criticism, not personal remarks, and even suggest experiments. If the conclusions are not fully supported by experiments, they may say to the authors, you know what, I do not agree with your conclusions. You need to do this in this experiment. So go back to the lab. That happens too. A good reviewer, or patient, I should say, reviewer also catches small errors, typos and things. That's not the job of a reviewer, really, but I appreciate it when somebody notices something that will make me look unprofessional if the paper gets published with some typos. Okay, and next one. And then the decision actually happens. So the editor receives all the comments from reviewers, and basically based on the comments has to decide, do I reject this paper? Do I accept it? Usually there are 3 types of decisions: reject, minor revisions, which means send back to the authors and they have to revise it, or some kind of revision, right? Or publish without any changes. That's extremely rare, but it happens. It may be a brilliant paper after all. So we go through all these things, and the important thing for an author and to learn how to address reviewers' comments. Normally, the editor says, well, these are the reviewers' comments. They're anonymous, by the way. When you submit your revised version of your paper, you have to address them point by point. You may not agree with some comment, but you have to explain why. And you may have to support your opinion, not to disagree, but based on maybe literature or something. So that requires a lot of reading actually to respond properly to the reviewer's comments. So we teach them all these things. So just to show them that writing a paper is a complicated thing. So let's go to the next one. I occasionally give students an assignment. Well, here is a paper, anonymous, right? So this is a manuscript, review it, write a review for this paper. And remember, you have to be objective and constructive. You should criticize the science, not anything else really, the novelty and all these aspects. And then they have specific time to turn in their reviews. I usually give them one of the papers that I wrote as a graduate student, removing my name, so they can criticize me. I can take criticism, you know, so it's fun what they comment on my own paper. So it's original manuscript from maybe 20 years ago. And of course, we give them some clues what exactly a review should contain. So this is the general structure of a review. Show that you have read it, show that to the editor who will be reading your review that you actually have analyzed it and you understand what's going on, and then of course make your suggestions. Okay, next one. And then these are the last steps. Once your paper gets accepted, you normally get your last chance to improve, make some cosmetic changes. It's called the galley proof. You get sent a PDF file normally, and you look at it and maybe catch some minor things before it gets really published online or printed in the journal. It gets assigned a DOI. This is called Digital Object Identifier. It's a number by which people can cite your paper, even if the final page numbers, volume number of the journal is not yet known. This DOI number actually can be cited. It's a way to identify a paper. And then some last types of pieces of advice here, how to make your paper more visible, more attractive. So this is done by a table of contents graphic, which many people have to do. So it's a summary of your paper, which actually tells to the interested reader, just by looking at it, can know what's happening. So to a chemist, that picture, to anybody else may look very obscure, but to a chemist, it tells you what this paper is all about. Sometimes if your table of contents picture is particularly attractive, efficient, it may end up on the cover of the journal. So this is how to make precise molecules, and this is an old watchmaker here, you know, just with the precision of a watchmaker. But I think it's a clever way to represent accuracy, precision in synthetic work. The very last one that I have is next slide, please. Yeah, is how to judge the impact of a scientist. So we mentioned briefly that impact factor of a journal is important, but that's really average, how likely it is your paper to be cited based on how many times other papers in that journal were cited. But really the important, the impact of you as a scientist or your work is really calculated by number of citations, which how many times other people cite it in their work. It served as a basis of new research. That's a good thing, of course. Citations are important. But really the most important way to judge the quality of a paper or its impact is or the author's productivity, if you will, is the so-called H index. So this is a number which tells you how many of your papers were cited more than H. H is a number, H times. So if you have an H index of 7, that means that no matter how many papers you've published, 7 of your papers have been cited more than 7 times, 7 or more times. So this takes into account the productivity of the author, because your H index can never be more than the number of your papers, but also how well appreciated they are. You may have 1,000 papers. If all of them are cited only once, that means a lot of productivity but poor quality. You have an H index of 1. So we're going through that type of, so that they know the impact, what that means. I'll stop here just to go to another class that Gary will present about how to write a report, how to communicate. It's a different type of communication, lab reports and this kind of stuff. So thank you very much. And we segue into reports, I guess.
I've been having a course that has had a writing tag, actually, and also an oral communications tag since pretty much all this century. And this is a course that has 3 hours of lecture a week, but outside of the lecture, there's a lab. And in that lab, students make MOSFET transistors. And it takes about 10 lab sessions to go through the process in the clean room. And then there will be a final report. But after each lab session, the students are expected to write up a lab report of what they did that day. And basically, the idea is that that's the material that will make the final report. So I think the lab reports are worth 100 points and the final report's worth 100 points. And there's probably about 1,000 points with homework and everything else. So those lab reports and final lab, that's the meat of the writing tag. But there's other opportunities for writing, and we have an oral midterm and an oral final write-up, and there's and the students after the oral midterm and final, they have to write up what we discussed. And so, yeah, the homework, which averages out to another 100 points, there's about 13 assignments. And those homework assignments are also not the usual engineering assignments, just have a lot of equations and scribbled, and you have to chase all over the page to find them. But there's actually a format required and a requirement to have words between equations to explain what's going on. And on Fridays, this semester is the last day of the week, class of the week. A student will present the homework solutions, and if there's been a lab that the prior week, they'll report on what was gone on in the lab and discuss about what went good and what went wrong and such. So this is just a picture. On the left is a 4-inch silicon wafer that's bare when the first day of the semester. And after about the 12th or 13th week of the semester, the wafer is completely processed and ready for testing. And that's what this picture shows. And if you look at the wafer, you'll see a whole bunch of little rectangles on that 4-inch wafer. And this is on the right is a blow up. And there's a row across the top that are called MOSFET, metal oxide semiconductor field effect transistors. And so far, every year, every student has had working devices. For that main writing assignment, so here I mentioned that the first lab, which is often the second or third week of the semester, when they finally get around to getting into the clean room, they're presented with a 4-inch wafer that's going to be processed into these transistors. Again, 10 lab sessions. The clean room's in the basement of Junkins. And I mentioned a lab report has to be uploaded after each week. And then in the final lab report, of course, there's what they did in the clean room. And a lot of the homework problems during the semester are related to what they're doing in the lab section. So calculations of the oxide, we have to grow oxides and we have to dope the semiconductors p-type since they start off n-type, and so there's appendices that are related to homework problems. And I have Appendix 4, which that just says, how does a p-n junction work? That a p-n junction is key to how one of these transistors work, how these transistors work. And that's the oral exam question. I tell them the first day of class what the midterm question is and what the final is. And they're required to write this up several times during the semester's homework and after the exams. But so there ends up being 7 appendices. The final one, when you do a semiconductor process, there's something like a recipe that you would have to bake a cake that tells you the order of what to do. And so they have that what we call a traveler that they can make their own comments on, and that's also included. And I've already mentioned that these oral midterms and finals, they're told what those questions are, but the way that works is in our clean room, we only have one mask aligner, maybe in which is a bottleneck. So we can't have 10 to 20 students in the lab at the first time. I tried that once years ago, but so the labs are all outside a classroom, and we get groups of 3, sometimes 4 students at a time, and that works out. And so that same group is also the oral exam group. When I first started giving oral exams, I just had one student at a time, but sometimes they would freeze up, and it turns out I also realize if you divide by 3, it takes a lot less time. We spend about an hour, and so that those groups get to know each other pretty well between the labs and oral exams. And what do I want to say? Oh, it happens to be the what I really want students to take away from the course is to understand, the physics of these devices. And it turns out that often when they go for a job interview, especially if it's a semiconductor company like Texas Instruments, or there's Corvo, there's a lot of local companies here, IntelliEpi, Photodyne, Coherent in Sherman, Global Foundries in Sherman. It's very common that they're asked one of those questions on the oral exam. So even though they don't like it, maybe having to be having the oral exams, but afterwards, when they have aced an interview process, they're very happy about that. Well, or at least they're okay with it. On the lab reports, students are graded on the format, mechanical accuracy, technical, anyway, and then all of that's converted to a grade. So they get that feedback on all the weekly lab reports. And from needs improvement or not meeting standards up to mastery or the comments. And there's a noticeable improvement from the beginning, few lab reports to the final lab reports. Let's see, I had a comment, something that was a bit surprising to me is that foreign students where English is the second language, they often are American-born English speakers, don't do that much better, or there's not that much difference as you'd expect. Okay, so I think that really hits on everything I wanted to do. There's some things I had to. I think the very first things to have a course that meets the writing tag, there's some forms you had to fill out, and I think that's where some of the first things came from. Maybe actually, I guess not, but there's some of that in here. But that's all I really wanted to get through today.
I have a question for all of you. How do you see AI impacting your way of doing writing? Because it seems to be such an important topic right now. And writing is one area that is heavily impacted by AI. And I'm curious what your thoughts are in the publication process.
Well, in my course, I do not allow AI because I want students to really get down into the foundations and even if your writing isn't smooth and perfect, that's really not what I'm judging you on necessarily in the first place. It's content development. And so we go through a lot of drafting processes so that I can see how students are developing out their thoughts. So I try very hard to design assignments that are not really, AI is not going to help them that much doing it. And I talked to them about the problem of AI being it's sort of kind of the Wild West. It makes up facts and statistics, it makes up authors, it makes up journals that don't exist. And there's a very specific kind of writing style to AI. It sounds very fancy and it sounds very highfalutin, but it's very shallow in terms of what it has to say. And so I tell them, I don't want you to turn in an assignment that looks perfectly polished with highfalutin language. I want you to turn in thoughts and ideas and arguments that demonstrate that you've engaged yourself in analysis and critical thinking. And so that's kind of how I handle it. And it's not to say that AI can't be useful for a variety of classes. When I work in the writing center, I occasionally get students who professor has instructed them to use AI for certain portions of paper development and whatnot. And that's totally fine. But for me, I'm not quite ready to kind of jump on the AI bandwagon. I really want students to go through it's like go through the process once you understand it, you know the nuts and bolts of it. And later on in your upper level classes where you have a professor that wants to use AI, you have that foundation available to you, but you can also use AI to get some help. So that's just kind of my take on all of it.
I don't think I have much to add here, but I do not, of course, encourage them. I want them to create their own work. Now, then the difficulty is how to catch them when they do actually use AI, and that's the constant cat and mouse game. You can tell sometimes from the way it's written. It's probably easier to catch it surprisingly actually in the arts when you have a little bit more creative writing. AI kind of stumbles. I have written poems written by AI, which you can tell were not human poems. Perfectly rhyming and all that, iambic pentameter, perfect and all that. But in science, it's probably a little bit more difficult to catch. But that's something how that will be the challenge for us, how to catch that.
Could it be useful to you in some way?
Certainly it can be. I think that all these things that were developed, even text recognition, which is a little bit different from what you're asking. So this is not to create a text, but to analyze a text, right? I mean, so whoever came up with deciphering, let's say, some very old text, extracting text from it, analyzing what it says, if you ask me, deserves the Nobel Prize. As a historian of science, I very often read stuff that was written in, 13th century or 15th century or in Latin, and I'm looking for that page that mentions specific thing. And so that type of analysis helps me very much. That's not what you're asking. I think this is about writing actually that you're asking me. So it could be, certainly it can be. It can save a lot of time for some boring things. Maybe once you perfect your writing, maybe you can then use some help, but get perfect first. Try to at least be as perfect as possible. That's what I tell students. Whether they listen or not, that's another story, right? But
I just want to jump in and add that I think it is useful in some respects for like searching for works that are connected to each other. Researching AI can be helpful with that. I think that students struggle with information literacy because they're new to the field. They haven't spent the years and don't have the experience or expertise to know when there's a scholarly conversation that's forming around a particular topic. And so let's say they want to research. I oftentimes let my students research stuff they're interested in and analyze that. So let's say I had a student recently who wanted to research specific kind of portrait paintings and the rhetoric of the portrait paintings, right? And so you can go in and you can do your search, but you'll find that the stuff you're pulling is somewhat unrelated, and students just don't have that experience enough to get that. So so it could be useful in setting them up to be like, you need to read this and this and this authors. But again, I caution people because it's still under development and they could make up a journal or an author that just doesn't exist. And that's kind of why we kind of pull away from it. But in terms of catching, the way it works in my course is we do drafting. We start with outlines of ideas and we move from outlines to rough drafts. And if somebody turns in a rough draft that looks to be AI enhanced, I will just sit down with them and have a conversation to say, this writing looks to me like it's AI enhanced. I'm not upset. This is a rough draft, but I really want to see your own voice, your own writing. So I'm going to ask you to go back and redevelop this rough draft so that what you're turning in is more in alignment with your own thoughts, your own ideas. And then if they do turn in an AI final draft, then it's trouble. Then we're getting in trouble. But I'm not getting them in trouble on the rough draft just yet. So it's kind of trying to steer them. So that's kind of how I handle the catching folks. But anyway.
I don't really have any I've experience with Chat GPT, and I'd like to try to, because it doesn't seem like it'd be very helpful in the technical fields I'm in, and I don't think it's helpful to the students writing these reports. But I did submit a paper to IEEE's Institute of Electrical Electronic Engineers. A lot of journals submitted with co-authors a paper, fairly long paper. I don't know if it's been a month yet, but when I submitted it, they asked, there was the option to use something called PaperPal, which is artificial intelligence, technical. They claim it's a technical writing AI or something. And I got the results back from that. It didn't change very much. It put comments where I didn't think it needed, but there was one section that it tried to rewrite. And what I realized, it didn't what it rewrote was not at all what I was trying to say. And so that was helpful. I didn't use any of that, but I did clarify what I meant. And I think it found it, there's things like when or there, and there's some words, and that was useful, but it never took sections and redid them. And I think that was a requirement on when you submit papers to this IEEE journal, is that you're supposed to identify any sections that are AI enhanced, but I found it very difficult and time consuming. But I don't know that I don't anticipate any problems in my class with these reports, because although maybe I'm just ignorant about that, and hopefully I will figure it out.
I think the specificity of your assignments precludes use of AI. And that's what I often recommend to folks who are trying to design assignments, is the more specificity you have to your assignment and the more specialization your assignment entails, the better chance you're going to have of people not using AI for it. So
Thank you very much.